I'm going to go through some use cases, and the first one is to create a pod, create a service, and these pod and the service obtain IP from Contrail. The service IP gets mapped to an external IP. Using this external IP, I'll be able to access the app that is running in the pod. First, I will create a demo project. Using the YAML file, I'm going to create the pods. The pod is a replication server, and I also have a service to create. It is using Kubernetes API version 1, and I'm using a particular image for this replication server. And next, I'm creating a service that is using TCP protocol and port 80. Now the pod is running. It got an IP and the service is running, and it also got an IP. It got an external IP. So let's see what happens. So this is the app that is running in the pod. It shows the pod IP and the container name. So behind the scene, what's happening in networking? We have a default network called cluster network that has two IPAMs, pod IPAM and service IPAM. Pod IPAM has this CIDR and service IPAM has this CIDR. And each pod gets created, gets an IP from Contrail. That's the first use case. So when we created the pod, a request came to the UI, OpenShift Origin UI. Then the request goes to the K8's API server. K8's API server contacts the Kube manager, which is a Contrail entity. And the Kube, and there is also a scheduler, Kubernetes scheduler, that finds which resource to use to spawn the pod. We have two nodes, worker nodes, and when it finds where to create the pod, it informs the API server, and it also sends the message to CNI plugin. It also sends a message to Kubelet. Kubelet sends the message to CNI, and it creates the IP and a MAC, and then this IP and MAC is assigned to the pod. That message is relayed back to K8's API server, and that IP also get maps to an external IP address by the agent. So let's go to the next use case, which is scale-up replicas and ECMP load balancing. For that, I'm going to use a guestbook app. Create a new project, and so this guestbook app going to have two Redis masters and 2 ready slaves and 2 front-end pods and 1 service. Again, I'm going to use YAML files. First, I'll create the front-end controller. That's a replication server, and it uses HTTP server, and next I'll create the front-end service. It's using target port 80, and it's using the Kubernetes construct load balancer. It will, because of that, it will get an external IP. Using that external IP, you can again launch the guest book, create the master service. It's using 6379 port, and the slaves. So done. So we have 2 Redis pods, and I'll increase 1 more pod for the server. And let's see whether we got the IP and external IP. Got the external IP, and that's the guest book. So that's the app that is running. Now this shows that inter-pod communication is working, and they are connected to the service, and we are able to access the service from outside. Now I'm going to show the namespace isolation. For that, I'm simply going to create an Ubuntu app in each project. Before that, I just want to show SVC all namespaces. So it shows all the namespaces that are available and their IPs, external IPs, all that port numbers, how long it has been active. So let's go create a isolated namespace. So the first project I'm going to create is isolated ns-1. If you see the annotation, it's set to true. Isolation equals true. cp create, OC create, OC is OpenShift CLI -f the file name, and then the project name -n. Here we have isolated namespace 1. Same, immediately it got updated. Same way, I'll create the second namespace that also got added. Now simply create an Ubuntu app here. So that's so UCML and we have Ubuntu apps. If I go to the Ubuntu here, it got an IP of 242 and the other one got an IP of 240. Let's see if they can ping each other. 242. Of course not. They are in isolated namespaces. When we create an isolated namespace, which is a Kubernetes construct, it creates a network policy. It gets mapped to 2 security groups, and also it gets mapped to virtual networks. Each isolated namespace mapped to one virtual network. Natively in Contrail, if you are in 2 separate virtual networks, the pod in one network cannot communicate to the pod in the other network unless we allow network policy, and then unless we explicitly create policies and apply policies to allow traffic. So there are 2 policies we need to apply. One is network policy. So for before I create the network policy, this is the Contrail UI. Here you can view the route tables. It would have created a route table for each isolated network. So we are seeing 242 here. We don't see 240 here. Likewise, if we go to so this is on the vroute 2, the other pod is on the other second worker node. So 242 is here in this worker node. Now let's go to the network, and I'm going to apply a policy to leak the routes from one network to another network. And apply this policy for those 2 networks, so that the routes get leaked to the other. So we go back and we can check the routing table. If we go to the routing table, now I should see 240 because the route got leaked. That's not the route, this is the routing table. You see both the routes are here. Now let's say whether it's still not going through. The reason being, we have a deny all policy created I need to allow traffic here. By default, no traffic is allowed. Ingress, egress, just the ICMP traffic I will allow. I need to do that for both networks. So Contrail natively segregates the network. In addition, these security groups were created because the network policy was applied on the Kubernetes side. So now the ping is working. One last thing, if you're interested, if I go to the introspect of the virtual router, I can see which policies are applied, which security groups are applied for which flow. So the traffic is flowing from 240. So if we look at this flow, it will show here which security group is applied. This is the UUID of the action is passed.